show MPLS interface order. Now have a look. What I told you that yesterday class, if you remember this part, LDP. What is LDP? It's a label distribution protocol. Split this word label. Label is for 20 bit of integer number. It's a 20 bit, right? It can be ranged from the 1 to 20 bit. Find the 20 bit. So this is the like a pool, right? This is like a pool. From this pool, what happened? I think so. It's a start from 0. It's not from 1. From this pool, what happened? Every LSR router. Every LSR router. Why I'm saying LSR router? Because this router is running with the LDP. Label switch router. Because this router is now going to forward the packet based on the label. For the packet based on labels, right? Every LSR router is take a label from this pool, right? This is the default pool right now we have. Okay, now this label assignment is done by the which protocol? LDP. So LDP is going to assign the label at the same time. Assign the label at the same time. What happened? Distribute the labels as well as. Is going to assign the label as well as at the same time it will distribute the label, and also it is going to perform the 3 operations that we have: pop, swap, and push. Pop is remove the label, swap means change the label, push means insert the label. So for example, if normal IP packet is coming, right? Normal IP packet is coming. Listen to me this thing. If normal IP packet is coming, what router? This router is a LSR router, right? What this guy is going? This guy is going to assign the label to this person, right? The IP plus label 20. This is the meaning of what? Push. This is the meaning of what? Push. Now take example. If the router 2 is going to swap the label, is going to change the label level 20 to 30. What is happening? Swapping from 20 to 30. Swapping. Done. Now, at the same time, another router number 4, what they will do? They will just remove this label. That's the meaning of popping. So try to understand from this PC what packet I'm sent, IP from this user, what packet they receive. So does this user get any idea about the MPLS? No. MPLS is only happen in the MPLS. Oh, sorry, ISP. User will not get any idea about that MPLS is enabled or not, right? So this 3 operation is all done by the protocol LDP. Then one thing, sometimes in your Cisco examinations, what happened? Your LDP will be disabled. Maybe from the ACL, you can disable the port number UDP 4646, right? You can disable the LDP as with the ACL. So make sure that your ACL should be allowed the 646 port number, and we can say that LDP as well. Okay. So guys, as I told you that LDP is going to assign the label, right? to all prefix, right? LDP assign the label to all prefix. So normally, right now, what happened? We have a something like this table on this router, right? This is normal router without MPLS. Without MPLS, what happened? We have a routing table, right? We have a routing table. At the same time, what happens from this routing table? I'm going to generate which table? SAP table. We can say the fifth table, right? FreeBase stand for forwarding information base. With MPLS, what happened? With MPLS, what happened? You still have this information, right? You still have this information, right? At the same time, what happened? We have a protocol over there. What protocol? LDP. What they will do? They will create a LFIP, sorry, LIB, label information base, and then LFIP, label forwarding information base. So from here, I'm going to create it over there. So this is done by the which protocol? LDP. And this is done by the which protocol? Sorry, which command? IP number. And this is done by the which command? Any questions, anyone? So basically, with MPLS, how many tables we have? 4 tables. Without MPLS, how many tables we have? 2. Without MPLS, a router is going to perform the SAP table lookup, right? With MPLS, a router is going to perform the LFIP table, right? For all prefix, right? What LDP is going to do? LDP assign label to all prefix, every single prefix, right? Every single one. So have a look over there. So MPLS forwarding table. 1 minute before I'm going to show you this part. Let me do one thing. Let me add some network over there, right? This is the network. Let me write on all the network over there. We already just /24, right? Done. Duplicate.
So that should be 23.0, right? First one.
Sorry. Yeah, of course, right. We need this switch into the 34.0, 45.0, then 6. So this should be there, right? This should be there, there, and there. This guy should be there, and this guy should be there. Do we have a loop back is advertised over there? All the 3.0, yes. So we have a loop backs as well as 2, 3, 4. So 2 should be this side, 3 should be this side, 4 should be this side, and 5 should be this side. All clear, topology now? Perfect. Now, what I told you that for every prefix, LDP is going to assign the label. And this label is a locally to the router. Right? Assigning the label is a locally to the router. Done. So if you see on the router number 2, what happened? Whatever the prefix we have, for all prefix, we have some label. See, I'll do one thing. Now, this is my which table? The command is that I've written over there. Yep. This is called L50. And based on this table, MPLS router, we can say the LSR router, right? Forward packet. What is the command to check this table? So MPLS forwarding table. Now, two things is happening over there. First of all, we have a local label and outgoing label. You can understand this part. Local label means what? Assigned by the local router. And then this local label information, save it, neighbor LDP router. Once the local label segment has done, then this local this local information share with the neighbor LDP router. So for example, if you have 1.0.0.0 prefix /8, right? LDP is going to assign this label as a 20 for this prefix. LDP has assigned 20 label for this prefix. So this is a local, right? This label will become the local label. This label will become the local label, right? Once R1 router share this information, once R1 router share this information with the R2, for R2, this label will become the same way. If I'm going to add a one prefix more, right? 2.0.0.0. I'm going to assign some different label over there, 30. So this is the local label for the router number 1, right? For the router number 1, this is the local label. Once I will share this information to the R2 router. This label will become the outgoing label for R2. Now clear? Right? Listen to me. What happened over there? If you see R2, right? R2 is assigning all the label, right, to all prefix local label that is done by me. I'm going to assign the 16 label, 17 label, 18 label, 19 label, 20 label, 21, 22, and 20, 23. And this label I'm taking from which range? This label I'm taking from this range. Where is the range? 1 minute. I'll look at the range. Here are range. From this pool. From this pool, this is the pool that is present on a every router. It same like your DHCP pool, same like a DHCP pool, right? So if you see this local level, what is the starting point is happening? 16. From 0 to 15, it's reserved one for different purpose. 0 to 15 is reserved. I'll let you know what are the purpose are there. Don't worry about that. Okay. But yes, the allocation will happen 16 minutes. Right? एक मिनट ना. बता हूँ पता नहीं मुझे भी नहीं मिला कमेंट तो बहुत अच्छा था दिखा था कुछ और okay that's not I'll show you that command later on. Now so local label means what assigned by the local to the router. Outgoing label means what outgoing label show MPLS forwarding table right. R3 is sending this information to you. So if you see this thing right now, I'll show you 1 minute. Can you see the R2? Take a one prefix, any of them, right? Take an example of 44.0 prefix, right? This prefix. What R2 is doing? R2 is assigning 192.168.45.0 prefix. What is the local label is happening? 22. This assignment of label is done by the router number 2, right? Its label is a local to the router. Same way, what happened? R3 is saying that, hey, I'm also going to use the same label. Duplication is there. Duplication is there. No issue. Because it's all local to the label is a local to the router. label is a local to the router.
Sir, I'm not understanding what those initial labels are, like 16, 17, 18.
Yeah, tell me.
So,
What's the
so what is it? So when you go to R2, sir,
hmm?
so what is that label where it says no label, local
Oh,
label?
that's I'm coming to the point. Don't forget this one part. No
Oh, okay.
label, pop label, pop label. Forget this point.
Oh,
This is a
forget
little
that.
bit high
Okay.
level. Yeah, right now forget this one.
Okay.
So what R3 is doing for same prefix, right? 192.168.45.0/24. What label I'm going to use? So what R3 is informing to R2? Hey, R2, listen to me carefully. R2 is also done the local label 22, right? R3 is also done the local label 22. This is the local label. What R3 is sending to the R1? Hey, R2, if you not send any traffic to this network, which label you have to use? So when R3 will send this information to the R2, hey R2, whenever you are sending any traffic to this particular network, you have to use which label? Label number 22. So this label will become a outgoing label for the R2. And which next stop I have to use? Which outgoing interface I have to use? So for this particular local label is 22, outgoing label is 22, prefix is this guy, outgoing interface is 1/0, and next stop will be 23.2. I have a complete information. I have a complete, guys, right now, ignore this part right now. Okay, I have a complete information. Same way, if you just have a look, take example of this prefix 6.0.0.0, right? What R2 is using for the 6.0.0? Local level 20, outgoing level 20. So local level is what? 20, LL. What R3 is using for the 6.0.0? Same local level is 20. So R3 is also going to use the 6.0.0.0.0 level number 20. This is the local level, LL, right? What about the R4 now? 6.0.0.0. Same 20, right? So R4 is also going to use the same level. I'm again repeating, it can be different as well as, because local label is a local to the router, right? Label is a local to the router. It can be different as well as. So 6.0.0.0 label number 20 and local level. Go back to the router 5. Someone mic is on, guys, please. What R5 is doing for this network? What is the local level is happening? 20. So R5 is also saying that, hey, my local level is what? Right? This is the local assignment. Now, listen to me. R5 is sending to R4, which level? No label. Sorry, R5. This is sorry. My local level 20. Because this is the local level, right? R4 is sending which level to the R3? 20. And R3 is sending which level to the R2? Right? 20. So can you see over there what happening? This LDP router, this LDP routers, what they did, they just created a own virtual path, right? Same like IP has a path, we have a routing table information, LSP, sorry, this labels are created their own path over there. This path is known as a LSP. Label switch path is a unidirectional. So LSP is a collection of labels. LSP is a collection of labels and it's a unidirectional. It's a logical, like the VPN concept. The VPN, we have a logical kind of tunnel over there, and through that logical tunnel, I'm forwarding the packet, right? So you can create a multiple logical tunnel. Same thing, you can create a multiple LSP as well as.
So can you just show the table again? Show MPLS forwarding table on R5. Okay.
Now, one thing is very important. What is the meaning of unidirectional? I can send my traffic from one path, the other traffic coming by the maybe the different path as well as. That's the meaning of unidirectional. Now, so which label I have used? 20, 20, 20. So if you see right now on a router number one, if you go and make a trace dot, make a ping first of all good, trace dot. Which label I'm using? 20, 20, 20. Because for R2, the same is outgoing level 20. For R3, same outgoing level 20. And for R4, same outgoing level 20. 20, 20, 20. Right now, duplication is there. And right now, this allocation, like the LDP allocate this labels according to the this according to the this pool. You have a ability to customize this pool as well as. You have a ability to customize this pool as well as. Let me show you this customization. What I can do, I can tell this person, hey buddy, 1 minute, let me do one thing. Right now, I'm just showing the labels. I didn't came to the operation part right now. Just I'm showing the labels, right? How you can manage the labels. Interface 0/1/0. I'm removing the no MPLS IP, right? Do show run section MPLS. I don't have any MPLS in. Do show run section. Put the same command. Show extension as MPLS. Best command to check the pre-configuration. No, nothing is there. R4 as well as. Nothing is there. R2 as well as. Nothing is there. And R3 as well as. Nothing is there. Now let's do one thing. On a R2, what I'm telling, by default, the label assignment is done from this range, right? What I'm going to do, I'm telling this person, hey, you have to use the label from this range. You have to use this label from this range. You have to use the label from this range, and you have to use the label from this range. Sorry. Right now, I'm just going to show you the learning perspective, right? Okay. Just going to show you the learning, you can define this thing, right? MPLS label range 16. That already I told you the 1 to 15 is the reserve, right? I said that okay, the label range will be 200 to 300. R3, R4, R5. Then do I need to enable the MPLS LDP protocol? No. By default, it's enabled. Do I need to enable the LDP router? No. By default, it's enabled. MPLS IP. That's it. R3, MPLS IP, MPLS IP, R4, MPLS IP, and MPLS IP. That every router will form the neighbor ship. So now if you see, show MPLS forwarding table. The label assignment is done by the according to the router range. What R1 is doing, the local label. Is router ID the same concept as the election of the router ID is same concept, the election of the router ID. But here the router ID is the different use, right? Here we need the reachability. I'll show you that thing. I'll come into the this path as well. Don't worry about that. Okay. Local label, if you see what I have assigned the label of the range 200, 300, right? So all the label assignment is done 200, 201, 202, 3, 4, 5, 6, 7. What Archie is doing the label assignment range 400 to 500, right? What R4 is doing the assignment range 6 to 7, right? And what R5 is doing assignment 8 to 1, 900, right? Now if you see what R5 is assigning the label for 6.0 network 804, right? So the local label for this network 6.0.0.0.0 is what 804, right? This is why this guy R6, right? Sorry, R5. What R4 is doing over there 604 LLB 604. What R3 is doing 404. And what R2 is doing 204, right? What R5 is telling to the R4, hey R4, if you want to send any traffic for this particular network, which label we have to use? So in this case, the R4 outgoing label will be what 804. Done. What R5 is telling to the R3, hey R3, if you want to send any traffic to this network, which label you have to use? Right? And R3 is telling to the same person to the R2, hey R2, to all LDP neighbor, not to R2, all LDP neighbor. R3 is telling to the R2, hey R2, if you not send any packet to this particular network, which label you have to use? So now if you just have a look, if I'm going to send the traffic trace shot, what happened? 404, 604, and 804. So now listen to me, when R1 is sending this packet, when R1 is sending this packet to the R2, how the packet is look like this. Source, I'm not going to write the MAC address, right? You know the basic MAC address concept. Source IP will be what? 12.1, and destination will be what? Right? This is normal IP packet, right? When this IP packet comes to this interface 0/0, when this packet is coming to this interface 0/0, is this interface participate in MPLS? No. Listen to me. When R1 is seeing the ping 6.6.6.6, so destination will be 6.6.6. It will create a normal IP packet. R1 will send this packet to the whom? R2. R2 will receive this packet on which interface? 0/0. Is this 0/0 is enabled with MPLS? No. This 0/0 is participating in which like a protocol? IP routing. So which table I have to check? LDP table or SAP table, right? Once R2 will receive this packet on this particular interface, right? It will look up the 6.6.6. Do we have this information in my routing table? Yes. At the same time, MPLS is also present on this particular interface, right? So what happened now? This router number 2, this LSR router is going to push the label. What label I'm going to push? According to my L5 table, right? According to my L5 table 6.0.0.0, what is the outgoing level is happening? From which interface I need to process this packet? To whom? 23.3, right? So what R2 will do in this case, R2 is going to push the label that will be a label number 404. After that, in the lay 2 header, we have a source MAC and destination MAC, as we know that. What will be the type field? Yesterday we have seen, right? 0x8100 for the MPLS unicast, and for the MPLS multicast will be 0x81 for it, right? R2, according to the L5 table, R2 is saying that if any packet is coming for this network, I need to assign this label 404 and it forward the packet to whom? R3 to this next hop, right? When R3 will receive this packet, what R3 is going to do? R3 is receiving this packet on which interface? 0/0. So which table? This info, this guy is running with the Ceph as well as, and this guy is running with the L5 as well as. I will give the preference to whom? L5. Question is why? Yeah, both is enabling them. Then why I'm giving the preference to the L5? Yeah. तो ये router नहीं है normal. See, this router is router as well as, and this router is LSR as well as, and this interface is SAP as well as, and this interface LP as well as. SQL. R3 के पास 6.0 का information नहीं है R3 के routing table में. They also have, right? But why they are looking the L5 table? Why they are not looking the SAP table? Because of label. कुछ भी मतलब. Because first of all, yes, LDP works on the layer 2.5 and packet works, sorry, IP works on the layer 3, right? So first LDP comes in the picture, layer 2.5, then L3. Second reason, that's not a like technical way. Thing is that what is the Ethernet header is saying that where should I forward the packet according to the Ethernet header? Layer 2.5. I don't need to forward the packet based on this particular things. I need to forward the packet to the home L5 table, not to the MPLS table. If somehow, listen to me, listen. Right now we have a L5. I'm talking on the R3 perspective right now, and at the same time we have a routing table. The person will first get to the L5. If R3 has a label information for this particular network, then it will send the packet to the appropriate interface, right? If somehow L5 is not present, then it will look up the routing table. And now it will send the R3 will send the unlabeled packet to the R4. He's sending the label packet, and now he will send the unlabeled packet because they don't have a L5 table. This point is clear. Any questions? Good. But right now they have. I will show you this practical as well as the unlabeled will happen. Don't worry about that. I'll just giving the introduction of this part. Right now, what happened? R2 will send the label packet to the R3, right? R2 will send the label packet to the R3. R3 will receive this label packet on this particular interface. They will perform the LFIP lookup. And according to the LFIP, what is the outgoing label is happening? Right? Have a look at the L3, R3. So because R4 is said that, hey, if you're not send any packet to me for this network 6.0.0, you have to use this label, right? Not the local. And I have to forward the packet to whom? 1/0 to 34.4, right? So what R3 will do? R3 will perform the which operation now? Right? So now it will just swap this label with whom? This point is clear. Once R3 will forward this packet to home, R4, right? Once R3 will forward the packet to the R4. What R4 is doing in this case now? R4 will receive this packet on which interface 0/0. This interface has the same CEF table or LFIP table. Because of the Ether type field, I need to look up the LFIP table. And according to the LFIP table, R4 is saying, hey, which label I have to use? What I'm doing, which operation I'm doing? Am I looking at the layer 3 over there? No. I'm only looking at the layer 2.5, right? And according to the R4, which next stop I have to use for the packet? 1/0 to this guy, 45.4, right? Sorry, 45.5. Sorry. Right? So now R4 will forward the packet to whom? R5. Once R5 will receive this packet, R5, which interface they are receiving? 0/0. 0/0 is enabled with the CEF and LFIP as well as, right? What they will do? LFIP lookup. According to the R5, what LFIP is saying that? Outgoing label. So what happened? No label for which interface I need to forward the packet? 1/0 to whom? Next of 56.6. So which interface 1/0, right? The no label means what? I need to push the pop operation. So what happened? Now, till this point, you will receive the R3, R4, R6. Sorry, R5. What R6? Sorry, R5 will do? They will just send this packet to the R6. Which one? Source will be 12.1 and destination will be R1 has created this packet and R6 received this packet. So this customer does not have any idea that MPLS is enabled in your network. This is how your MPLS is going to be work if everything is fine. And this will become my LSP. Same way the return traffic will come and it will look up for the 2 alert one. This point is clear how these things are working.
Law, if you don't mind, can you just explain it for 1.0 also from R6? Just very quickly. I just want to be
1.0. Do you want to recap?
Yes, yes, sir. I'm just little confused. I just want to be sure that I understand it
Okay,
correctly.
okay. No issue. So first, what R1 is doing, R1 set the ping 6.6.6.6. So R1 will create a this normal packet, right? Just 6.6.6. R1 will send this packet home. 1 minute. Let me do one thing. Let me go to fresh. Okay. R1 set the ping. Source IP will be, destination will be, send this packet to home 0/0. On this 0/0 interface, what happens? SEP will be enabled, not the MPLS. It will look up the SEP table, and I need to forward the packet to home R2. If you see on R2, we have a SEP table, right? I need to process the packet from 1/0, right? So what happened? Once R2 will receive this packet, what R2 will do? R2 this interface enabled with the SEP and MPLS. So MPLS router will perform the push operation, right? And what this guy will do, it will insert the label for this 2.2.2.6.6.6.6.6, which label I have to use 404, right? Once this packet come to the R3, right? What R3 will do, on R3 this interface is running with the SEP and MPLS, right? What they will do, they will look up the MPLS table because of the layer 2.5, and R3 will look up the MPLS table. And he said, hey, according to me, I need to forward the packet home. But before I'm going to do swap operation, right?
A second. So the 200 to 300 was assigning on R2. This was 400 and 600. 400 to 500 was on R3, right? वो जो labels थे sir, वो एक बार ऊपर लिख सकते हो sir?
अच्छा, हाँ, why not? So this was the label I have done, 200 to 300, 400. Those guys are 5 to 6, right?
Okay, yeah.
एक मिनट, one showdown section in base. 2 to 3, this one.
Okay.
And this one is the 4 to 5. This one is the 6 to 7. And this one is the 8 to 9.
Okay. So for 6.0 on R2, your outgoing label is 404 and incoming is 204. Okay.
So what happened? R2 will send this packet to home R3. And what R3 is going to do? R3 will look up the L5 table, and according to the L5 table, I need to use which outgoing label, right? Swami, let me know if your questions, if you have it till this point.
No, sir. So this is doing the swap operation, right? R3.
Of course. Yeah. Even
Okay.
R4 will do the swap operation. Now R3 will send this packet to the home. They'll let me swap the label 604 now. And then R4 will receive. It will again perform the swap operation. 804 now. And it will send to home R5. And what R5 will do? R5 saying, hey, no label. Pop the label. I need to do the operation. Swap, swap, pop, push.
Thanks, Lo. Got it.
Up there. Try to understand. No label. Right? Pop label. No label. Pop label. Up something. If I'm going to make a trace shot to the 5.5.5.5 loop back, what happened? This is loop back of the alpha. देखो क्या हो रहा है यहाँ exactly right. Why they are doing this thing? हाँ हाँ बोल 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 सही बोल रहे हैं भाग जाए यहाँ से सी R5 एक मिनट यार try to understand if I'm going to trace out to R5 what R2 will do in this case when this packet is coming to the R1 source will be 12 R1 destination will be right R1 will send which packet to this guy normal IP packet normal IP packet R2 will perform the which operation assign the label according to the L5 table right which label I have to assign 403 I need to forward the packet home R3 what R3 is doing over there which label I have to do which operation I'm doing swap what R4 will do in this case why the packet is on R5 right why they are doing the pop over there try to understand the destination is where R5 but who is doing the pop operation R4 see either the two things will happen and find which one is a better solution either they will look at the L5 table they will look up the L5 table एक मिनट रुको destination this guy okay case number one it will look up the L5 table it will look up the L5 table and it will look up the L5 table it will look up the L5 table at the same time routing table right in this case what happened every daughter will perform the L5 table at the same time last daughter will perform the routing table right second case L5 table L5 table L5 table but here I'm seeing the which packet tagged packet right label packet we can say it here I'm sending which packet untagged so which table I'm going to look up which one is the better solution why second is a better solution hmm? On order of 5 reduce the processing to avoid double lookup. To avoid double lookup and we can say that reduce the processing because every time a single lookup is going to consume some amount of memory right recursive lookup pata hai recursive lookup in a recursive lookup what happened first I'm going to look up for the next hop second I'm going to perform the lookup for the what exit interface so same thing is happening first I'm going to perform the lookup for the L5 second I'm going to perform the lookup for the routing table this is done by the mechanism is known as a PHP pen ultimate hop popping pen ultimate hop popping by default PHP is enabled on every router after enabling the MPLS PHP stands for pen ultimate hop popping before the one MPLS router, they will just remove the label, so that before the one MPLS router, they will just remove the label, so that what happened, the router does not need to perform the 2 times of lookup. So in that case, what happened, I'm reducing the CPU, and we can say that to avoiding the double lookup. So in that case, what happened, if I'm sending the, if this person will send the untagged packet, R5 no need to look up the LFIB, right? They just need to look up the routing table. So for every directly connected route, what happened, every person is going to do, my neighboring router is doing the pop operation. Same way, if you see, in this case, R4, what R4 is doing for the on loop back, R4 is into the R3 as a no label, as a pop operation, right? And R3 will send the pop operation for this network, right, to the R2. So if you go to R2, so all, not only for the loopback, all that directly connected out, not only for the loopback, all the directly connected. So if you see on a R3, how many directly connected out we have? 3.0.0 and 34.0.0. So R3 is sending this person, hey, for this network, and for this network, what we have to use? Pop label, pan ultimate hop popping, PHP. R4 will send this information to the R3, hey, for this network and for this network, you have to use the pop, because of the PHP. And R5 will send this to the R4. Hey, for this network, you have to do the PHP. Sorry. Okay, this one is also there. Done. Any questions, anyone?
सर R4 में 45 वाला नहीं दिख रहा है सर, R4 में
देखा ना, R3 पे देखेगा ना तुम, R3 पे देखोगे ना, you have to check on R3.
अच्छा, okay, yeah, okay.
On the neighbor, you have to check on the neighbor, right?
Neighbor, okay.
This point is clear. Anyone has any questions? Ethernet header. Okay, 1 minute. Take minute. On a Monday, I need to know the complete meaning of this part. लिख लो. On a Monday, I need to know the complete meaning of this part. हो गया? Now, come to the point, this guys. If you see, when R1 is sending this packet, right? Have a look, guys. When R1 is sending this packet to the R2, right? In this Ethernet header, what happened? We are type field is IPv4, right? When R1 is sending this packet to the R2, normal IPv4 packet, right? When R2 is sending this packet to the R3, same source, same destination. In between, what header am I adding? Do we have any header in between? See the difference. Because Ethernet header is saying that I need to forward the packet home, IPv4. Ethernet header is saying that I need to forward the packet home. Done. After that, what happened? In MPLS, we have a MPLS label, right? This guy is a 20 bit of label, right? Okay. This three fields, I'm not going to explain you right now. Okay, we have a separate practical on this three fields, right? What is the use of TTL, bottom stack, and experimental field, right? This MPLS level is a 20 bit, and only the four fields are present in your MPLS header. And the size of MPLS header is a 4 bytes. In the 4 bytes, what are 20 bit is going to represent the MPLS label. 3 bits will be this guy. 1 bit, I think so, this guy, and 8 bit will be this guy. So total will be 32 bit. So normally what happened when this guy is sending the packet to this guy is sending the IP packet. This guy label packet. This guy label packet, and this guy label packet, and this guy IP packet. So of course, but MPLS header is 32 bit. What is the size of IP4 header? See the difference is happening. Now, this is my MPLS LSP path, label switch path. Label switch path, LSP label switch path is a unidirectional, and it's built by the forwarding information base table, right? A collection. The LSP contains the collection of labels, right? LSP contains the collection of label. Let's take example. What happened if I'm going to break this LSP? Take example something like this now. See, sorry, like this. How many LSP is there now? LSP1, LSP2, right? So tell me, will R1 will able to forward the packet? What do you think? Will R1 able to forward the packet to the R6 in this case?
When you say break, which means that interface is down or something of that sort, or
No, physical interface is up.
physical
I'm
is
just
up?
going to break the MPLS path. This is the logical MPLS LSP path, right? I'm just going to break the LSP path. You can say that.
Break in the sense I'm not understanding. So you basically are just going to disable
I'm going to remove the MPLS from this interface.
MPLS.
Understand
Okay,
this way.
okay. Yeah.
Have a look. Just go to router node 3. No IPsap. No label. No label. एक मिनट भैया, that's the thing. क्या हो गया? अरे पैकेट जाना चाहिए भैया, अब जा तू। ऐसा क्या होता है क्या? एक मिनट भाई। But packet will be forwarded by the router. एक मिनट, एक मिनट, let me do anything. Man. See, I just remove the MPLS from this interface, right? No MPLS is enabled. What happened? Label packet, right? Unlabeled packet, because MPLS is not there, and label packet. This thing is only happen with your because in your MPLS path, MPLS unicast, I'm coming to your SEF question. If you have any question regarding the SEF, I disable the SEF and this was not working. I'm coming to that part as well as 1 minute. If you disable the, sorry, if I'm going to disable the MPLS over there, what happened? Now this first of all, what happened? It will look up the forwarding table, L50 table, right? If something is not present in the L50 table, what happened? It will go for the SEF table, right? If something is not present in the LPP, I have to go for the SEF table, right? Now, do we have an L50 table right now on this interface? No. So what they happen, they will forward the packet from the SEF table, and on the SEF table, we don't have any label. We don't have any label information, right? So they will forward the packet as a unlabeled packet. So in between, the LSP is not present. So we have a LSP1, LSP2. So we can break the LSP. So in MPLS Unicast, you are able to ping because R3 has a information about 6.0.0 in the routing table or SEP table. But in MPLS VPN, what happened? The core router does not have any idea. They will break the packet. They will drop the packet. They will drop the packet. So LSP is very, very important. Your LSP should be present. If your LSP path, label switch path, your LSP is not present, you cannot exchange the data traffic. In MPLS, because in MPLS Unicast, what happened? We have a routing table as well as, right? So if something is not present in the alpha, I have to go for the routing table, right? And based on that, I will follow the packet. But what happened in MPLS VPN? You don't have any information in the routing table, as I told you in the first day of the lecture, right? In the MPLS VPN, what happened? Nothing is there in the routing table. Only the LSP is there, right? So if the LSP goes down, whole network goes down. Now this safe part, guys, which iOS I'm using. 1 minute. एक मिनट ना. Typing is yes. Sorry. Sorry. रुपीस तुम 10 मिनट बाद 10 कॉल. Guys, just give me 2 minutes. Okay, let me. I just want to see one thing because the stuff I have done this thing in 12 hours was many times, right? Okay. Same IBM continue, right? Right now. I just want to try to show you that, yeah, if the SAF is dissolved, you are able to ping it. In the 15, that's a 15.0 version. It's a 12.0 version. So maybe the different IOS, maybe the behavior has changed, right? That's why. Okay. So SAF you are disabled, so your LSP has some complete change. Okay. And now if you see on R3 what happened, he's saying that tag means what he's talking about the label switching is not even, right?
But traceroute, why is it not showing R2 and R5 on
Complete the complete LSP had changed. It's a different of the iOS version, right? Complete LSP had changed. LSP is not different.
But on R2 and R5 you didn't disable Ceph, right?
No, I have disabled the SAF on R2. It's still there. Maybe it will take some time. 1 minute. Untagged, because R3 is not going to send any information. All the untagged is there, right, on R2. How this thing will be work? R2 will send all untagged information to the R2, right? R3 will send all untagged information to R2. How will they put the labels over there? All the untagged is happening, right? R3 send all untagged label to the R2, right?
Acha, but in that other iOS, it was not happening this way, right?
Yeah,
It was totally
it's
different.
breaking the LSP. It's again the depend on the platform by platform basis, right? As
Sir,
but
I
yes,
think this R2 is different, sir. This R2 is that other wala. I think you're supposed to.
other
I think it is from the previous wala R2. This routing table.
है कुछ
There is
नहीं.
one. There is one more R2, no, sir.
Where is R? अच्छा तो ये देख लो, इस पे देख लो तो
हाँ हाँ. Yeah.
सेम आउटपुट मिलेंगे दोनों को.
Acha.
It's totally depend on the platform or platform basis, right? Because even if you see, I'll show you the docs, one docs are there I have. Okay, so not today, on the Monday, right? We will go through the books as well as. So I'll show you the, if you disable the SAF, your LSP complete will change, right? So if you have a routing table, based on the routing table, they will follow the packet, but all the packet will be unlabeled. Okay, but in MPLS VPN, this will be not possible, because MPLS VPN core router does not maintain the any routing table information. So the packet will. Yeah, guys, any questions, anyone? Yeah. That we haven't discussed as far. See, I'll tell you, we have only done with the 1 minute. I have only done with the, max to max 5 to 10% of the MPLS access, right? Okay, so we have a two neighborship. I'll show you. Basically, we have a two neighborship according to the RFC. The name is basic neighborship or extended. I think so. This one, right? Maybe. Take a basic or extended. Yeah, basic and extended. We'll discuss this thing not now. Okay, we'll discuss this part. Good. Any questions, anyone? Akansha, Mahendra, around Devendra, Srikant, Swami, and Vijit? Okay, guys, then see you on the Monday.
Have a good weekend.
Happy weekend to you guys, and all Mahashivratri. Happy Mahashivratri. Thank you.